Hello my people, you are welcome once again to my YouTube channel. Here we discuss anything concerning maths and physics from primary school level, secondary school level to tertiary institution. Our today's topic will be electricity as regards the request of one of my YouTube subscriber that said that she need more explanation on electricity. So I decided to take the electricity from beginning to the end. And if you are new around us here, click the subscribe button and don't forget to click the notification bell so that you can get first-hand information. This will also enhance me to do more of the videos and it keep us going, as that's what we really need to grow this YouTube channel. Now let's go to the business of the day. The real business of the day. Let's start like this. What is electricity? What is electricity? Now, electricity can be defined as the study of flow of charge. The study of flow of charge through a circuit. Through a circuit. Now this means that this topic itself is a study that deals with the flow of charge through a circuit. So some things are very important there. Flow of charge, then a circuit. These are the things that will determine everything we want to do here. Now, what are the contents in this topic? Content, I've started already, is number one, definition of electricity. Number two is parameters of electricity. Number three is type of circuit. Types of circuit. Number four is to discuss Ohm's law. Ohm's law. Number five is arrangement of resistor. Arrangement of resistor. I omitted something there. After this, we'll be joining it with symbol of electrical components. Electrical components. After that, we are going to discuss cells arrangement. Then We'll discuss the efficiency of a cell. Efficiency of a cell. Then we are discussing to that resistivity, or we say that factors. Let me just call it resistivity. Factors affecting resistance of a wire. That one will lead us to resistivity. Number 9 here to be discussed are some instruments we used here, starting with meter bridge, Weston bridge, Weston bridge, Weston bridge, Stone bridge, potentiometer. After that, we are going to discuss electrical energy and power. Number 10 is electrical energy and power. After that, we'll discuss conversion of galvanometer to voltmeter, and we end it with conversion of galvanometer to ammeter. Now, these are the contents to be discussed, and I've discussed the first one. What is electricity? Electricity is defined as the study of flow of charge in a circuit. That will take us to what we mean by the study of charge. Why is charge different from current? We'll get that when we discuss the parameters of electricity. That's the next thing here. Parameters of electricity. Actually, I can't finish all these things today because they are what? They are lengthy in nature. So what are the parameters of electricity? There are 3 parameters of electricity. And they are one, the current. 2 is voltage, and 3 is resistance. Now let's take them one by one. One of the the parameters, I said current. What is current itself? Current can be defined as this, can be defined as the rate of flow of charge. That is why you see some people will tell you that electricity is the study of flow of current, like I define as flow of charge here. So it's the real flow of charge to that. Another definition we can give this is to say that it can also be defined as the quantity of charge per time taken. Time taken. Now look at that. Anytime you say rate of anything, rate of anything means over time. If I say rate of pencil, it means pencil over time. Here I said rate of charge, it means the charge per time taken. Now let's go mathematically. Mathematically, let Q equals quantity of charge. That one is measured in coulombs. Coulombs. Column C. We have time. This is time measured in seconds. Seconds S. Then current, which is what? I. What represents current here is I. Now, what's the meaning of this? From the definition, it means that I is equal to quantity of charge per time taken. Time taken. Now, what is the unit now? Unit of current equals ampere. Ampere, where written as capital letter A. You know this one is measured in coulombs and seconds, time is measured in seconds. Now here, where 1 ampere is equal to 1 coulomb per second. So from this, we can easily see that 1 ampere is same thing as what? 1 ampere is same thing as 1 coulomb per second. That is what current is and the way it is what measured. Now I feel we should solve a question before we go ahead so that we can be happy and we can get this right. This one is still simple. We've not gotten to the conc part of the work, and when we get there, you will enjoy it the more. Once again, I want to say that if you are new to this channel, quickly click the like button, subscribe button, and join the settings so that you can be part of the work always. Now, Let's see a question so that we can get it right. I won't be saying I don't even understand what the man is saying. There's a question here that says that, now example, we want to solve an example. The question goes thus, so that we can be happy. Says that ten milliampere of current was obtained when for 3 minutes in a circuit. Calculate the charge, the quantity of charge flowing in the circuit. So see the question. So this is the question. Let's now solve the question. So from what we are given here, they said that 10 milliamps produced. That means I here is equal to 10 milliamps. Milli here means 10 times 10 raised to power minus 3 ampere, and that's equal to what? 1 times 10 raised to power minus 2. Then we're given time. Time is 3 minutes. And we can't leave a minute to be in seconds. That will be 3 times 60, which is equal to 180 seconds. The question is to calculate charge. We now say, but I equals Q over T. That is Q equals IT. And that is what? I is 1 times 10 raised to power minus 2. Then T is 180 seconds. And that will give us what? From here, this is 10 raised to power 2 minus 2. So it will give us 1.8 coulombs. That's the final answer there. So with that, we see that it's quite easy. It's not that difficult to solve. Now, the next thing here is to look at the instruments that are used to measure what? To measure current. What are the instruments used for measuring current? We have many like that, and that will assist us to do justice to many things here. Now, spelling at times is a problem. Where is that? Okay, I wrote wasting here. Let me just rewrite that part so that we can be happy. So it's wasting. Let me rewrite it well. Width is like width. Width thing. Yes. Sorry about that. Now let's go to our calculation, our instrument. Instrument for measuring instruments for measuring current. For measuring current. What are they? Number one here is ammeter. A-M-M-E-T-E-R. Number two here for measuring this is galvanometer. Galvanometer. Number three here is multimeter. 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 These are the instruments used for measuring these currents that we have here. Now, let's take the next parameter. What's the next parameter here? The next parameter is voltage. What is voltage? The number two part of our discussion. Voltage. Voltage. Voltage can be defined as the work done in taking a charge through a circuit. So why is it work done? Because it is, when you say work done is like energy. So the energy you get after using your electricity is the work done. For instance, look at the light produced. When you see the light energy you see there is in form of work done. It's energy. So that's why it is very wrong scientifically to say that you have low current. No, it is low voltage. What you see there is voltage, not current. Low voltage or high voltage. That's the best thing. Now, voltage is divided into two. Or it is measured. It is measured in volts. Voltage here represents V, capital letter V. Why this one is small letter V? What are the instruments used here? Instruments used for measuring this. A part there is voltmeter. The second part here is potentiometer. Potentiometer. We also use multimeter here. We also use galvanometer because we can convert it to voltmeter at any time. Galvanometer. The fourth one is called multimeter. You can see that we use this one also in the current part. Now, we have two types, voltage. Voltage is divided into two. namely A. Electromotive force. Electromotive force. That is called the EMF that we know. While the second part is potential difference. Potential difference or voltage drop. Voltage drop, which is called PD. Now let's take the A part. That is electromotive force. Electromotive force. EMF. What is that? This can be defined as the work done in taking a charge. Round a circuit when no current is being delivered to a load or a resistor. Now, this one, it means no current is passing through what? The resistor. And that is why it is called electromotive force. You see this EMF? The EMF is how to get the voltage, total voltage of the cell. You won't allow anything to pass through the cell, and there is no other thing connected to it. So that is electromotive force. Second one, that's B, which is what? Which is voltage drop or potential difference. Potential difference or voltage drop. This one here is called PD, potential difference. PD. Now, what is the meaning of this? This can be defined as the work done in taking a charge from one point to another in a circuit. So you can see that this one is from a point to another point. So that at a point you have a potential, at another point you have a potential. So the voltage is dropped there. I will explain further in this. Now, when current is being delivered to an external load or a resistor. So here you see the difference between the two. The other one take it around the circuit, no current delivered to anything. But the second one is just from a point to another point, and there's a load in between there. Current is being delivered to it. So this is the difference between the two. Now, the next thing we are going to discuss now is number 3. What's number 3 here? Number 3 is resistance. We use R to denote this. Resistance. This can be defined as the ability of a material to resist or oppose the flow of charge through it. That is, it will allow the flow of charge through it, or flow of current, or the path of current through it. Now here, example of this material are Conductance wire and magnetic wire. Now, this is just it. Now, it is measured. In ohms. We write ohms like this. Now this shows that what offered resistance to the flow of charge is called what? Is called resistance. Now what are the instruments used here? Instruments used here. Here, the instrument, the first one here is meter bridge. Second one here is Wheatstone bridge. All these ones we are going to discuss them later. The third one is ohmmeter. The fourth one is resistance box. The fourth one, or fifth one to say, use the galvanometer like I did for others. Then we have multimeter, multimeter. Now, these are the instruments used. Now let's go to B part of this resistance. It has a twin brother. Called 3B, that is conductance. What is a conductance? So it's like opposite to resistance. So that one is represented by C. Now here, this can be defined as the ability of a material to allow the flow of charge through it. Now, this one, we have conductors like metals, many like that, but it is measured. It is measured in Siemens. Calculator S. So now here, let's note this, that a material that resists the flow of charge through it is called a resistor. See that? A resistor. While a material that allows the flow of charge through it is called a conductor. Now, there's a relationship between the resistance and the conductance. Resistance relationship between resistance and conductance. This relationship is so easy. What's that? You know, resistance is R. C is always equals to 1 over R. That is, C is inversely proportional to resistance. Increase in resistance of a material reduces the what? The conductance. That's sure. Now that relationship there will give us some things to denote here. Deduction from relationship, Deduction from the relationship. What are the deduction we get from this? Number one is that a good resistor is a weak or poor poor or weak conductor. Then a good conductor is a poor resistor. Now note that there is a difference between being weak or poor and bad. It means that a conductor can also be a resistor, but its performance is very low, very low. So that is what will now take me to number 3. That is, all resistors do conduct, but their level of conductivity is very small compared to their level of resistivity, which means that the resistivity is very high compared to conductivity. They also conduct little, but not as so significant as the resistance that they do. Now, all conductors do resist, but their level of resistivity is very low, or small to say, low compared to their level of conductivity. Now, this is where we are going to stop for today so that the video will not be too much for us. So the next class we'll be discussing types of circuits, Ohm's law, if you can get arrangement of resistor. Tomorrow, I pray that there is enough time for me to give us more explanation on this. I remain that man, Ogbon Tajudeen, the maths and physics coach. If you still want to join our free class, it is for both JAMB and SSCE. So you are free to join. The Telegram group is there, down there in the description part there. Then, if you are new to us here, to this channel, quickly click the subscribe button so that we can grow this YouTube channel together. At the same time, you click the notification bell so that you can get first-hand information. If you like this video, please click the like button and remain yourself. I believe you are happy now. More are still coming. This is just a tip of iceberg. More are still coming. See you when I see you. And bye for now.